As we prepare for your lab, where we're looking at the dynamometer performance, I wanted to spend a few minutes here to introduce you to the equipment that we're going to be using, so that you have an idea of what you're going to be doing. You can prepare. Your lab handout will give you more information about exactly what we're going to do, what we're going to try to measure, or what we're going to do with the data and so forth. But I just wanted to introduce you briefly here to the equipment. So this is the dynamometer, or one of them. We have two of them that we're going to be using. This is one of the dynamometers. It's a very, very simple device. You can see it connected here to a tractor chassis. So that blue chassis in front there is actually a prototype chassis, and we'll work with that. We can abuse that one and put all different kinds of fuels in it, so we'll have some fun with that thing. It's everything except the wheels and the cab, if you will, connected to it. The red boxes on the back is the dynamometer, the thing that's on wheels. And basically what it is a brake. So inside that smaller red box on the top there is actually a large brake drum. And the shaft, the red shaft that you see connecting that dynamometer to the tractor, is what we call a power takeoff. That is a rotating shaft, and almost all tractors have that. So they have a shaft on the back that I can connect to that gives me rotational power to some kind of implement that I'm going to connect to that tractor. So power takeoff shaft there rotates, spins a drum inside that small box on the top, and there's brakes on it. So when I want to load the tractor, I just put the brakes on, and it starts to make it hard for that shaft to turn, and it adds a torque load to that engine, and that's going to try to slow that engine down, slow the whole tractor down. So now, because I'm doing that, because when I put brakes on there, I'm trying to slow something down, I'm going to build up a whole lot of heat. So the bottom red box there, that big box in the bottom, is just a big water tank. And we'll actually connect the hose to this thing and run fresh water through it to keep it cool so it doesn't get too hot and melt down for us. But that's how we'll keep the thing from getting too hot for us. All right. Let me talk a little bit about that power takeoff shaft and that power takeoff that comes out of the tractor. Again, this is actually a standard, and we'll talk a lot more about standards later in the semester. But there are standards that dictate what that shaft should look like and how fast it should turn. So this gives us some commonality when I have a tractor designer who designs a tractor and another manufacturer that designs an implement that I want to put on that tractor. They can develop something, and they know it's going to connect up and it's going to work. And so that shaft has a standard size of a spline coming out of it, and we'll look at those in the lab. And there's a couple different standards, and those standards correspond to different speeds. And so for lower power applications, there's a smaller shaft, and it is standardized to turn at 540 RPM. So when the implement manufacturer that develops a relatively low horsepower implement knows that, hey, I'm going to have a shaft coming out of the back of that tractor that's going to spin at 540 RPM, so I can design the rest of my implement off of that rotating shaft. Now, for higher horsepower, that shaft is not big enough to handle the horsepower, so what we do is make a larger shaft. So it's a little larger shaft, and it's going to spin a little faster. So instead of 540 RPM, it's going to spin at 1,000 RPM. So the higher speed means I don't have to carry as much torque. So I can carry the same amount of power through a drivetrain with a higher speed and lighter components and smaller components, and so I don't have the component failure. And so we'll see both of those standards. So some of the tractors will use the 1,000 RPM standard, and we'll use a 540 RPM standard. But again, it's a standardized connections. We can snap these shafts on. We can connect them to a lot of different tractors, and everybody expects that to be there. Okay, look a little bit more at the dynamometer and how we're going to do the measurement. There's the back end of the dynamometer. Again, there's a big drum in the front there. You can see near where that yellow valve is in the center of the screen. That's the center of rotation of that drum. And that drum would just rotate freely if we didn't have that long bar on there. And now you see out on the left-hand side of that bar, that is a load cell that's going to measure force. And so that load cell is going to keep that bar from turning, and at the moment arm, which you'll have to determine in the lab to figure out what that moment arm is, we're going to measure the force that's on that cell, that load cell, and that was going to tell me how much torque that tractor is developing, or alternatively how much torque that dynamometer is putting onto the tractor and how hard it's resisting that. Okay, so that bar would rotate freely, but we keep it from rotating with that force transducer out on the end of the bar. The electronic box you see up on the very top of the image there, that's just going to be a digital readout, so we'll see what's on there. So when you're in the lab collecting data, you're going to be looking at the force. You're going to be measuring force off of that electronic box on there, and with the dimensions of the whole system, you'll know what torque, how much torque that thing is developing, and you will also be able to measure the speed of that shaft. And we'll have a couple ways to do that. Some of our newer tractors have electronic readouts in the cab, and so we can utilize that. We also have some tachometers that shine a little light beam and little electronic devices, and we put a piece of reflective tape on the shaft, and we can actually measure how fast the shaft turns that way. So we'll be able to see what the shaft rotation speed is. Okay. Now, one of the things to keep in mind, that we're going to be measuring the rotation speed of that power takeoff shaft, and that's not the same rotational speed as the engine. So because of that engine, and if I go back to that dynamometer, that chassis, the engine sits up on the front of that chassis, and there's a transmission between that engine and that power takeoff shaft in the back. And so there's going to be a speed difference. So that engine is probably going to be running at about 2,000 RPMs or something like that when that shaft is running at 540 RPMs. Okay. Now, the other thing that you're going to get a clue about is think about what the rated engine speed is. And that's one of the things that we're going to try to figure out, because the manufacturer will give you a rated power for the tractor that occurs at a certain speed, at the rated engine speed for that tractor. Well, what is the rated engine speed, and how do I know what that is? Well, again, that power takeoff shaft is designed to be operated at a certain speed. So the manufacturer is probably going to have that peak performance of that engine occur at the speed where that power takeoff shaft is at its correct speed. And so that's going to kind of clue us in a little bit if we watch that power takeoff speed when it hits that sweet spot, either 540 or 1,000 RPM, depending on which standard that we're using. That's going to tell us that's probably what the manufacturer would consider to be the rated engine speed or the rated performance point for this particular engine. So those are going to help us to clue in and determine what's going on there. So that's the equipment, and again, look at your lab, the handout before you come to lab. Understand what you're going to do. The lab will go a whole lot smoother if you have an idea before you get there. Try to read the lab the day of. You're going to be there, not going to get finished. So a little preparation makes the lab time go really slow, and we'll have time to have some fun then and do some extra things if you get your data early. So there you go, and I'll see you guys in lab.